Ohm's law. You know what is the meaning of Ohm's law? Yes. What is Ohm's law? Ohm's law says that, yes. Ohm's law states that, what is Ohm's law? According to Ohm's law, potential difference is directly proportional to current. If we remove proportionality sign, everyone knows who will come. Yes, who will come? Yes, resistance. A constant. That constant is R. R is resistance. Always remember this R is a villain. Why? Why this is villain? Because he will take the charges. He will eat the charges. Because of this, at the final output will get the less current because of resistance. Okay, so according to what is V? V is potential difference. What is R? R is resistance. What is I? I is current. So according to Ohm's law, current flowing through conductor between 2 points is directly proportional to voltage across the 2 point at constant temperature. Yes, here make sure your temperature should be constant. Okay, Ohm's law. So in Ohm's law, what is current? Current is represented by I, voltage is represented by V. And what is Ohm's law? Ohm's law states that voltage is directly proportional to current at constant temperature. Where R is what? Where R is your resistance. And what is resistance represented by? It is represented by Greek symbol, Ohm. Okay, this Ohm. SI unit of resistance is ohm and it is represented by symbol ohm. This is the ohm symbol. The size and substance of conductor are two factors that affect resistance. The size and substance. See, resistance depend upon the size. It depends upon the area. It depends upon the length. And it also depends upon the substance. Substance means it depends upon the material. It is simple to calculate R on the conductor size in the manner shown below. I will explain you how we can find the R. Okay, so once again I repeat this, what is there in the slide, then we'll proceed with the factor that affect resistance, the factor which affect resistance. Okay, the first thing, first what we studied about the Ohm's law. Ohm's law states that voltage is directly proportional to current. When we remove proportionality sign, what I will get R, and that R into I. What is R? R is resistance. And what is resistance measured by? It is measured by a device, resistor. And what is the symbol for representing resistance? It is ohm. Okay, and resistance depends on which factor? It depends on material. It depends on material and size. What do you mean by size? Size means area, size means length. Okay, then yes, see, it depends upon the area. It depends upon the area. It depends upon the length. If you increase the length, see, first in the first case length was L, in the second case length was 2L. So as the length increases, resistance will increase. As the length will increase, resistance will increase. Let us consider an example. If this is the length, if I am giving 10 charge here, I will get 8 charge here. If I'm in input, if I'm giving 10 charge, I will only get 8 charge here. But if I double the length, if I'm giving 10 charge here, I will only receive 6 charge over here. Why? Because length had been increased now. Length has been increased now, therefore resistance will be increased. So from this slide, what we will conclude? We'll conclude that resistance is directly proportional to length. Okay, then from second slide we will conclude that if we increase the area, we are not increasing the length. In the first case, what we did, we increased the length. It was like this, we increase it to double. But if we increase the area, what will happen? See, if in the first case, if I am giving 10 charge here, I will get 8 charge here. Okay, but if I increase this thing, So what will happen if I double the area, resistance will drop. If I increase the area, resistance will drop. Resistance is dropping. That means what? It is inversely proportional to area. From the first case, I concluded that your resistance is directly proportional to length. But from second case, I am concluding that your resistance is inversely proportional to area. If I'll combine these two equation, if I combine this equation 1, if I combine with this two equation, what I will get? I will get resistance is directly proportional to length per unit area. Check. Length per unit area. And we know if we remove the proportionality sign, kaun aayega? Yes, if we remove proportionality sign, there will be a constant, and that constant is known as what? Yes, that constant is known as, anyone in the comment section, what is that constant known as? Shamta, what is it? What's that constant known as? Yes, that constant is known as rho. That is resistivity. After removing proportionality sign, you will get a constant. That constant is known as resistivity. Okay, we'll get a constant. That constant is known as resistivity. Now, what will be the unit of resistivity? Anyone? Unit. What will be the unit? Anyone in the comment section? What will be the unit? Yes. How we can find the unit? See, resistivity can be equal to, this is R, this is A. RA or what? Over L. RA over L. Resistance is represented by ohm. Area is represented by meter square, and length is represented by meter. So meter and meter square will get cancel, and what you will get? You will get ohm meter. Ohm meter. This is what? This is your resistivity. This is the unit for your resistivity. This is your unit for resistivity. Okay, now, yes, see, this is rho. R is equal to rho L upon A. If you want, where rho is the proportionality constant, where rho is proportionality constant. If you want to write in the Ohm's law equation, that is V is equal to IR, you can write I into, what is R? R is nothing but rho L over A. Okay, yes. Then we have current density and conductivity. First of all, you know what is conductivity? What can be conductivity? Anyone? What can be conductivity? Conductivity is opposite of resistivity. It is opposite of resistivity. Conductivity is opposite to resistivity. What was resistivity? See, what was resistivity? Resistivity was RA over L. Conductivity is usually represented by G. It will be L upon RA. L upon RA. What is L? L will be in terms of meter. What will be resistance? Resistance will be in terms of ohm. What will be area? Area will be in terms of meter square. So meter and meter square will get cancelled. You will get 1 upon ohm. You know what is 1 upon ohm known as? Yes, 1 upon ohm can be written as this symbol. Into meter is down, you can write it as meter inverse. This is nothing but your mho. Previously it was ohm, now it is mho. See, ohm you will represent by this symbol. Ohm you will represent by this symbol, and mho will be represented by this symbol. Just the inverse, just the inverted image. This is ohm and this is mho. So you understand what is conductivity? What is conductivity? It is a reciprocal of resistivity. What will be the unit? Unit will be mho meter inverse. Okay, next what we have? Next we have current density. We have completed conductivity. We have current density. What is current density? What is the meaning of normal density? Which density, about which density you know? What is normal density? Density is usually, yes, mass per unit volume. Mass per unit volume. But what is current density? Current density is represented by capital J. It is current per unit area. It is current per unit area. Current per unit area. What will be the unit of this? How you will represent current? Current will be represented by A, ampere. And how you will represent how you will represent area? Area will be represented by meter square. So your current density will be current per unit area. It will be represented by J, and it is I upon A. Okay, now we have a short derivation. We have short derivation for our current density. We have this formula. We have formula like we have formula that EI is equal to J rho into L. What is E? E is the magnitude of uniform electric field. What is L? Length of a conductor. What is I? Current. What is J? What is J? Yes, current density. J is our current density. So what you can do, you can write it as so you can write it as E is equal to J rho. You can write it as E is equal to J rho, and from this you can say, and from this it is possible to express the relationship for magnitude E and J above in vector form. Along with being directed along E, the current density is also a vector J. So from above equation we will get E is equal to J rho. And what is J? J is nothing but your rho into E. And what is rho? Rho is, in this case, our rho is our conductivity. It is usually represented by capital G, but in your CBSE book, it is represented by rho. Sorry, it is represented by sigma. Okay. Achha, if current density, what is current density? What is current density? Current density is represented by J. It is current per unit area. My question is, this is a scalar quantity or vector quantity, and why? Anyone? The question is, current density is scalar quantity or vector quantity? Current density is a scalar quantity or vector quantity? Yes, it is a vector quantity. If it is a vector quantity, that means it will have magnitude and direction. In which direction current density will be there? Current density will be in the direction of current. Current density will be in the direction of current. It will be vector, and it will be what? It will be in the direction of current. Okay, then yes, the question is the question is which of the following graph represent the variation of current through a metallic conductor with its terminal potential difference? A, this one. B, this one. C, this one, or D, this graph. I repeat the question. It will be, I repeat the question. Which of the following represent The variation of current through metallic conductor with its terminal potential difference. First one, like this parabola. Second, in the straight line, incomplete parabola, or this parabola, D. Anyone? D. B. Why Kanika B? Nikhil B. B. Okay. Why B? Why B? Any logical or justification of the answer? Yes. Yes. Correct option is option B. Why B? Anamika, why B? See, we have relation. V is directly proportional to current. It means what? If V will increase, current I will also increase. It is directly proportional. See, and how it will goes up. It will go up linearly. Linearly means if you have one voltage, let us consider you have 1 ampere. If you will go to 2 voltage, you will have 2 ampere. If you're going to 3 voltage, you will have 3 ampere. Like this, if you are linearly increasing the voltage, linearly your ampere, your current will increase. That's why, which will be your right answer? Your right answer will be, your correct answer will be option, yes, option B. Option B is the right answer.